Commands and scripts are a great way to run a whole bunch of related simulations and to organize them. You can do batch mode, run and log multiple IV curves by varying one parameter, make for loops. You can spell out the relationship between different variables by mathematical formula, etc. etc. So let's pull up the command window, and you'll see that it consists of a box where you can type in a command as well as a list of commands. And as said before, there's a command corresponding to every action you can take on the graphical user interface. So for example, if I want to go to design H pattern, we'll find that there's already such a command. So if we type that, and it doesn't matter if it's large or small caps, that takes us to the design H patterns page. Then of course we can type title screen, and that brings us back out to the front page. If you click into the list box, the command which you click will be automatically shown in the command line with an explanation. So the explanation says goes to the title screen. That's simple enough. And you can also scroll down to see all the remaining list of commands and what they do. These commands are sorted by group. For example, execution commands, things you can do in the design H pattern screen, things you can do in the mesh screen, things you can do in the simulation screen, the base transport calculator, cell cross-section, stuff like that. Or you can arrange all these commands in alphabetical order. There's over 200 commands, so in this video we hope to show you the main ones. So as you're scrolling through the commands, if you hit enter, that brings the focus into the command line, and if you hit enter again, it will execute. So again, we can go back to the title screen. There's also an auto suggestion feature, so if you type up the beginning part of any command and hit tab, it will return you the first command that begins with whatever you type, and from there again, you can scroll through to find the one you want. Finally, for your convenience, you can also search for the history of commands that you have inputted by going into the command line and hitting the up and down arrows. So if I hit the up arrow, I get to the last command I made, and then I hit up arrow again, I go to the design H pattern command, which was the second last command that I executed, and so on. And so I can scroll through all these history of commands very conveniently. So what you'll find is that you'll be mainly using commands in the simulation screen. So what we're gonna do is just make an example of a monofacial solar cell, and that gets us to the simulation screen. And we're just gonna pull up the command window here. Now one of the main commands you're gonna use is find JSC VOC MPP, corresponding to the button that you push the IV curve. So if I type find and hit tab, that returns this command. If we select this, then there's no difference from hitting the find JSC VOC MPP button to run the IV curve. But what's interesting with commands is that actually you can do more than that. So there are two ways you can call find JSC VOC MPP. There's a straightforward way corresponding to just pressing button, and then there's this other line below which you have to pass a few parameters. And that enables you to run multiple IV curves while varying any cell parameter. So let's take a look at the explanation. Runs many IV curves, each case varying the desired parameter in the range defined. For every case ran, Griddler logs the important IV parameters as a row in the summary text file. So one example is find JSC VOC MPP temperature 25, 55 temp series.txt. So if we look at the syntax of this command, temperature is the parameter to vary, 25 is the starting value of temperature to use, 50 is the end, 5 is the increment of temperature which is scanned in the range, and every time Griddler finishes running an IV curve, it logs the IV parameters like VOC JSC MPP into a text file called temp series.txt. So in this case, if we are interested in varying the temperature, we can just hit enter and finish the rest of this line, temperature 25, 55, temp series.txt, and we hit enter, and Griddler is gonna run a whole bunch of IV curves varying the temperature from 25 to 30, 35, 40, 45, and 50. And at the end, it also conveniently plots content of the summary file as 4 charts of JSC VOC fill factor and efficiency, so you can clearly see how the efficiency is dropping with temperature. And if you wanna pull up the text file yourself to look at it, it's right here. So you see that Griddler has neatly written down into this text file the main IV parameters for each case as a single row, and then there's one row corresponding to each temperature. Alright, So find JSE VOC MPP is one of the most often used commands in Griddler because of its ability to sweep through any cell parameter conveniently. If you actually want to browse through the list of cell parameters that you can sweep in particular, they are actually conveniently displayed in this drop-down menu whenever you call up this find JSE VOC MPP command. And there is a heap of variables you can vary. For example, if we want to know how detrimental the front grid contact resistance is to the efficiency, we may select front finger contact res. And then we can define the range we want, like for example, starting from 0 to maybe an extreme number like 50 milliohms centimeter square in steps of 5. And we call that vary contact res.txt. We run that. And now we have a plot of efficiency, fill factor, JSE VOC versus front finger contact resistance. And by the way, this was done at a temperature of 50 degrees. So let's reset that to 25 for now. And we'll reset the contact resistance to 0. Now, one of the things with find JSE VOC that we will most likely have as a sweep parameter is the number of front grid fingers. And that often is our question as to how many fingers is optimum for the front grid. Obviously, more fingers introduce more shading, and less fingers introduce more series resistance in the lateral current flow in the emitter layer, along the fingers, and in the contacts. So this front grid optimization is often about finding the optimum number of fingers that will balance these losses. So one way of doing this is similarly choosing find JSE VOC MPP and sweeping front fingers num, which represents the number of front fingers. We can select that and we can say, okay, we choose to sweep in the range maybe 50 to 150, varying by 10. And we save everything in front fingers sweep.txt. We can do that. And now you can see that Griddler actually goes back out to the design page, redesigns the pattern, and now it starts at 50 as number of fingers. It will run the IV curve of this pattern. And when it's done, it's going to go back out to the design H pattern screen, and then it will set it at 60 fingers and rerun the IV curve, and then it will go to 70, 80, 90, all the way till 150. Yep, so now we'll come up with the trend of efficiency versus front fingers num, and you can see clearly there is an optimum somewhere, and that's in the neighborhood between 80 to 90 fingers in this case. So by the way, you can actually save this as a picture. Alright, so in this case we can find the optimum number of fingers by using again this find JSE VOC MPP function with a sweep. Now if you routinely need to find optimum number of fingers and you want to find the exact number for the optimum, I guess you don't want to sweep through every single value of finger from 50 to 150 because that would be a crazy number of IV sweeps. So for this situation we have another very useful command, and it's called optimize front fingers num. There's also another one called optimize rear fingers num in case you have a bifacial solar cell, but in this case let's focus on one of them. So the syntax is similar, so we have optimize front fingers num, range from, range to, summary file name.txt. So in this case, Griddler intelligently searches through a range as defined by the lower and upper number of fingers, for example 50 to 150, and it saves again the trends as it searches through this space in front fingers opt.txt. So let's do that. 50, 150, front fingers opt.txt. And again, Griddler now begins with 50 fingers, runs the IV curve. But what it will do next is it will run 150 fingers and run the IV curve. And then it will start using a kind of bisecting method by going to 99 and 100 fingers, and then it will look at the data to see where the optimum number of fingers lie, and then it will keep approaching this optimum using a bisecting method until it nails down the exact number of fingers corresponding to optimum. We get a more exact number. namely 83 fingers. So there you have it. Feel free to browse through the other commands and check out what they do. In the next videos, I'll teach you how to use build to create a series of commands in the form of a script by recording down your actions in the graphic user interface with the purposes of running a series of simulations to predict the rooms for efficiency improvement. We'll also look at for loops and the use of eval to vary more than one cell parameter at a time and to also spell out the relationship between parameters as they're varied.